Okay, so 2.4c.
On the homework, I said, what do you mean, like, review and, like, 2.4c?
Oh, really?
Yeah.
How many reviews are there?
I think it's just, it says 2.4c/review.
How many points is it? Be able to do all of them. Okay. Okay, these are a little bit different. So far, we're going to do tangent lines still. But what we've done is we've been given an x value to find the slope at, and instead we're going to go backwards. They're going to give us the slope, and we have to find where it's occurring, okay? So like it could be something like this. Here's your parabola, and I could say find the point where the rate of change, where the instantaneous rate of change, the slope, equals like 12, okay? And you have to find whatever point that's at. Maybe it's up here, you know, like you have to find the coordinates. Yeah, so before it was find the slope and tell me, or here's a point and tell me what the slope is. Now here's the slope and tell me what point that is. Yeah, and we're going to do 2 of these. So here we go. Number 1. All right, it says here that y equals 3x squared plus 6x minus 1. And we want to find the point where there is a horizontal tangent. Okay, there's many ways to do this one. We're going to do it the way that we've been doing it all along with the limit as h goes to 0. Okay? Find the point where there is a horizontal tangent. So this problem can be done in algebra. It can be done in Ham. It can be done in calculus. There's so many different ways to do this one. But you're going to be told to use the limit as h goes to 0. Okay? We're going to be told that. So let's talk about this. If our tangent is horizontal, then what's the slope of it? 0. Yeah. Okay? So m is going to equal 0. We want to find out where that's going to occur. All right, so let's do it. Here we go. Take the limit as h goes to 0. Would you like to try this, or you want me to walk you through it again?
No,
walk us through it? Okay, perfect.
Wait, I'm confused. How is this different?
It's different because before it was find the slope at x equals 3. Now it's saying, here's the slope. You have to tell me what x value it is.
So how do we even do that?
Yeah, so we're going to find the slope, or we're going to find the formula. I'll show you. Here we go. So we're going to go 3 times x plus h squared plus 6 times x plus h minus 1. I hope you're getting pretty good at these. Minus f of x, which is 3x squared plus 6x minus 1, all over h. So what we're doing right now is we're finding a formula for the slope at any point, okay? So the limit as h goes to 0. Here we go. We got to do a whole bunch of algebra here. We're going to FOIL this out as we distribute the 3. Okay, so we get 3x squared. Our middle term is 2xh times 3, so 6xh. And then the last term is h squared times 3 is 3h squared. Then take the 6 and distribute it to that middle term there. So plus 6x plus 6h minus 1. And then take the negative and distribute it to all the parts of f of x. We're subtracting the entire function. So minus 3x squared minus 6x plus 1 all over h. Woo! Okay, let's start doing the fun part. Let's cancel some stuff out. So 3x squared and negative 3x squared. Positive 6x, negative 6x. Negative 1, positive 1. So I'm left with the limit as h goes to 0. Everything I have that's left has an h in it, and I'm going to factor that h to the front. So I get 6x plus 3h plus 6 all over h. The h's reduce. I take that 0 and I plug it in. I evaluate the limit as h goes to 0. I can use direct substitution now. And I get 6x plus 6. All right, so that's not new, right? Now, the thing that we did before was I would say, okay, at the point, or when x is 2, tell me what the slope is. But this is different. This says, tell me what x is when the slope is 0. So what should we do? Yes, we're going to set it equal to 0. Because the slope is 0. I could have said, find the point when the slope is negative 10 or 12 or whatever, or 3 or 1/2. But they said at 0 when the slope is 0. So let's subtract 6, divide by 6. X is negative 1. Okay, that's not the point though. The point is an x and a y. So take that negative 1 and plug it back into your original function. So we're going to do 3 times negative 1 squared plus 6 times negative 1 minus 1. Did you get it? You think it's negative 4? Let's see. It's 3 minus 6 minus 1. Yeah, I got negative 4 also. Did you?
Yeah.
Negative 4.
So is that the answer?
That's the answer. And you know what we just found? When the tangent is 0 at the point negative 1, negative 4, the tangent is 0 at the vertex. We just found the vertex. That's exactly what we did. At the point negative 1, negative 4. We could have done this. I'm doing this with my Algebra 2 kids right now. We use this formula. X equals
Can we just plug it in the graph?
negative b over 2a. I know, right? We do it that way in Algebra 2 where we get the axis of symmetry and then we plug it back in. You could also go to your calculator and hit minimum, right? It's the minimum of the graph. But that's where the tangent is 0. You're like, thanks for making us do all that. Oh, you're going to be mad at me next chapter when you find out that there's shortcuts to all of this. All right, number 2. Here we go.
Why do we burn it?
Oh, you have to. You have to do this first. I know, calculus students get mad every year. Like, yeah, seriously, especially when you get to the next chapter and you're like,
Derivatives, 'cause, like, Edmund tried to teach me
yes, Edlin's not supposed to teach you derivatives, though.
We have to know it.
I know,
I
he
just
shouldn't
feel like
have.
you could change the chapters up.
Mm.
Something else that didn't need derivatives.
Didn't have derivatives. Find an equation for each tangent to the curve that has a slope of negative 1/4. All right, one more of these. So we're told that f of x is 1 over x minus 2. And I want to find an equation of each tangent. That sounds like there's more than one. Each tangent that has a slope of negative 1/4. That has a slope negative 1/4. Okay, so same type problem like the last one. This time we're given the slope and we have to find the x values and then we have to find the equation of the tangent. So here we go. Do you want to practice this? These are tough, yeah? No? Yeah? Ooh, Trevor, good job. So try this on your own. Plug in, do the whole thing, okay? This is good practice, the limit as h goes to 0, and use the function 1 over x minus 2.
So I can have like negative 1 over x plus h minus 2 times x minus 2.
Mm-hmm.
So then I take away the h
Yes.
and then have x minus 2 squared.
Yes. All right, so you get x plus h minus 2 minus f of x all over h. Okay, you need a common denominator. We just did one like this from the homework. They are tough. You need to multiply this top and bottom by x minus 2. I know. So that you get x minus h, or plus h minus 2 times x minus 2 minus x plus h minus 2 over x plus h minus 2 times x minus 2. All of that's over h. All right, so when you subtract here, you're going to get x minus x will be gone. I get a -2 minus a -2, that's gone, and I end up with a -h. Be careful, that's always going to be -h. And then on the bottom, I have x plus h minus 2, x minus 2, and this is all over h, but I like at this step to change it to 1 over h and multiply. All right, so then h and h will reduce. Don't forget to take the limit as h goes to 0. Plug that in for this h, and you end up getting, oh, sorry, we just did the limit. You end up getting -1 over x minus 2 squared. Okay, so that's just the first part. Now I have to take that and I have to set that equal to -1/4. Are you having trouble trying to solve this?
Can we FOIL out the bottom?
Yeah. So I would probably cross multiply. And you get -4 equals -x minus 2 squared. I just get rid of the negatives because you don't need them. So you get x minus 2 squared equals +4. Foil that out.
Or you just take the square root.
Ooh, yeah, you could do that. Let's do that. I like that so much better. Let me erase this. Yes, why wasn't I thinking that? Yeah, take the plus and minus square root. Well, there's two answers. So you get x minus 2 is 2, x minus 2 is -2. So x would be 4 or 0. Wow, two answers. Okay?
Is that why it's like each tangent?
So now we have two tangents to find. So when x is 4, what's the y value? We're going to go back to the original. F of 4. 1 over 4 minus 2. So that would be what, 1/2? Gross. And then you would also over here do x is 0, -1/2. Okay, so let's go ahead and find the tangents for each of these. So our slope's the same, point's different. So we're going to go y minus 1/2 equals -1/4 x minus 4. And then this one would be y plus 1/2 equals -1/4 times x. Perfect. You can leave them in point slope form. If you were to graph this, you can graph it on your calculator. It's 1 over x minus 2. You might know what that looks like already. But here's the graph of it. There's an asymptote through x equals 2. Did I not graph this right? Oh. There's an asymptote through x equals 2, and there's an asymptote at 0. Okay? And your graph looks like this and this. And we actually found 2 points. You found x equals 4. 1, 2, 3, 4. And that slope is -1/4. And then also at 0, look at this. See? They both have a slope of -1/4. These lines are parallel to each other, and they happened at 2 different points on the graph. Everyone gave up.